range. Okay, so okay, so yeah, I guess everyone can see my screen, including students online, can see my screen and hear my voice. If you cannot hear me, just let me know. Okay, thank you. Don't mute me again. Right. Chapter 4. So last time we talked about shear and moment phase not phase, shear and moment diagram. Okay, and hey, okay. So last time we talked about really important concepts that we will have several types of support. The support has pin, roller, fixed supports, and hinge has 2 reaction force. Roller has 1 reaction force. Fixed support has 3 reaction force. Okay, and not all the force. Okay, 3 reaction. 2 of them are force. 1 of them are moment. Okay, and type of load, yes, point load, distributable moment. Okay, and the biggest things we need to emphasize here is that when we do the force balancing, we typically transform from distributed load to effective point load, which go through the shape, the centroid of the shape. Okay, so if you have trapezoid, you will advised to make it 2 of the effective loads. One is going through rectangular, the other go through the triangles. Okay, and then oh, this is a really big things for you. That convention in our course, we will choose when we cut the materials and we are going to see the internal force like shear, like moment in that particular section. In this course, we leave left-hand side and then we adding the force we are going to derive on the right surfaces. Okay, so here we are going to choose here, not here. Otherwise, you will have exactly the same value but opposite sign. Okay, because they will cancel each other out, right? So here, if we draw the diagrams, we always pick the value here. Okay, pick value here. And when you firstly draw the figures, you draw downward and upward M, downward V and upward M. The value for this V is positive. Okay, although this is a little bit different when you are going to do the force balancing. When you do the force balancing, this downward has minus sign, but just really want to emphasize to you that when you do the shear diagrams, you draw the value in the shear diagram. This V is downward positive. Okay, so this is 2 words. Okay, 2 different things. So don't mix them up. Okay, so we pick up this right hand side. Okay, well, we leave left hand side and then we write the V and M on the right hand side. Very important. Otherwise, your answer will be has a sign different. Okay. And then last time we finished our courses at this problem, right? The first one is that we're going to determine the V and M right left, just a little bit left to the middle point. where we applied an n0 moment, and past that point, we have once we pass that point, the point has the n0 applied moment, then what will it be? Okay, what kind of change in shear stress, shear force and moment? Okay, so last time we determined the first one. So we cut this and we leave the left hand side, and then we drag down to the V and N. Okay, that's it. And then we do the force balancing, and we have V become this one, then N become that one. Okay, no problem. And oh, and also I forgot to draw this one. Okay, this is highlight. This is the answer for the left for the problem 1. And now we're going to determine problem 2. The problem 2 is just a little bit right to the center. So you see, and also cut it. Okay, we cut it, and then we leave left hand side and we write down V downward and N upward. Okay, so this is our definition. And then we found that because we just a little bit off the center, so we have N no appear here. There's no N no. Okay, here we have N no here. So we need to do different, well, exactly the same procedure, but different result now. Sorry. Here. Force. Okay. Sigma Fy equal to 0. So RA minus P and minus V equal to 0. So your V equal to minus P divided by 4 minus N naught divided by L. Okay, again, this is the answer. Exactly the same, right? So it tells us one thing. Applied moment and no won't affect the change of the shear stress, shear force. Okay, even you apply a moment, shear doesn't change from left to the right. Okay, so this is the value tells the result tells us. How about moment? Moment N V. Okay, so sigma N and what? And a blue dot. Okay, let's write down a blue dot here. Okay. Yesterday, last time, some student asked me, what does that mean? Because I saw his note. He forgot to write down this one. Okay, so he cannot understand why I do the force balancing. So please, this one. Okay, careful. I'm going to use the blue dot as the origin that do the moment balancing. Okay, so sigma N no equal to 0, right? So minus RA L over 2, right? So you see minus, why RA round about the clockwise minus, and this is half L, of course, because you just cut a little bit off to the center. Of course, you see this one is a little bit far away from the center, but well, because it's small distance, slightly. Okay, so forgive me my exaggeration in the illustration. All right, so half L, and plus P L over 4, right? Because P make the counterclockwise to the blue origin. Then and no is clockwise. So it's always minus. So minus and no. And n. How about n? Your n is counterclockwise, so should be positive. N equal to 0, right? So after that, oh, I wrote the result. After that, ta-da, n equal to PL divided by 8 and plus and not divided by 2. Okay, so you see minus and plus. Did you notice that? If we apply a moment like that, clockwise and no, it will make the n here become more. And what's the difference? What's the difference? One is minus and no half. The other is plus and no half. So their difference is n no. Okay, you see that, right? So their differences is n no, right? So their differences and no. So you can imagine that when you draw a moment diagram, you will see a immediate jump of the value of the n because of the n norm. When you draw the moment diagram, so just give you an example. So if you draw a x and this is m, okay, and then at that point, half L point, and then previously this is something minus NO divided by 2, and then suddenly after this point, ding, it will jump. So for example, if it's like that, something like that, it will jump. It will jump at that point because of NO. Okay, so yeah, this is ugly, but I just let you know that later you will see an example exactly like that. Okay, so jump. The NO will, the moment value will jump because of the clockwise moment, apply moment. Okay, so you can imagine that because the NO going to do this, right? You have NO like this. So if you need extra NO applied, so if you need to maintain the balance, you need to have a counter M in the material. Otherwise, this material will fly away or rotate like hell, right? So when you have a clockwise M NO applied, your M need to has a counterclockwise M to cancel each other. Okay, so which means that it will directly affect the moment inside the material. So your external moment will has immediate effect on the moment. OK， 听懂吗？就是啊，你的 M0加上去，例如说这边是顺时针，那你想想看，你右边如果没有那个 M，它就会一直狂转，一直狂转。所以为了要让它抵消，让它在这边还是保持平衡状态，你就必须要有一个 counterclockwise 的 M。好，那这个 counterclockwise 的 M 就正好让，也就是这个 M 就是变成是正值，对不对？哈，所以说当你在画那个 M 的图的时候 ，moment 的图的时候 ，diagram moment 的图的时候，原本它是负，就是可能比较低，是因为它减，它这边一个值减一个值啦，它比较低。结果现在一过那一点就变，一过那个 M0那个 apply 那个点的时候，它就暴增 M0，所以就嘣跳起来，所以那个 M 就会那个画的图就会有一个 jump 跳起来，那个中间那个差值就会是 M0，你施加的那个 M0，所以你施加的那个 M0会马上的影响到材料里面的弯曲的值。 但是它对它的剪力却完全不会有影响。OK， 很神奇吧？啊，OK，so external moment will immediately affect or change the material, the moment inside the material, but it doesn't change its shear force. All right, so continue. So I will give you next example will be a typical problem in chapter 4. Okay, very typical. So let's continue. 这礼拜我做什么？哦，完全记不得我这礼拜在做什么。我还真没什么特殊的事情，好吧，算了，再说吧。Next one. Oh, sorry, not example. So let's go through that. Let me take a look. Okay, right. So let me take a look. Sorry. Right. Let's jump. Let's jump to this one. Okay. I don't know which PDF, but it should be PDF 14. Okay. So let's skip a little bit. This one, something like that. We skip a little bit. Let's go to the example first. All right. Go. So this is a typical question. A beam with the support and then with the applied force, and then they want the problem asked me to draw shear force diagram and the bending moment diagram. Okay, so let's do it. So before that, I will give you an example that how to draw moment shear diagram and moment diagram. When you get this is a problem, right? So I will ask you to draw lines here. Okay. Okay, there are two figures. One, this is 0. Okay, and this is x direction, 0. Okay, and this is shear diagram, and this is moment diagram. So actually, we have two figures. Okay, the first one is shear diagram, the other is moment diagram. All right, so let's take a look. Sorry, I need to make it slightly downward a bit. All right. The reason why I'm going to do that is because I'm going to draw the reaction force now. So this is the answer will look like. You will plot your answer on this chart. All right. Shear diagram, force diagram, moment diagram. Okay. And then we are going to solve that. So let's firstly reaction force. There are two reaction force on hinge. Okay. RA and HA. But do we need to consider HA? No, because there's no horizontal force. So it's okay. And this one, RB is vertical, so only one. So we have two reaction force. Let's solve that. Okay. And okay. And then let's start. And now, let me take a look. RAP. Okay, let's do it. So, how do I write it? Right, sigma NA equal to 0, and then minus PA plus RBL equal to 0. Okay, and then RB equal to PA divided by L. Okay, no problem. And if you have sigma Fy equal to 0, we have RA plus RB minus P equal to 0, and RA equal to PB divided by L. Okay, so you solve the reaction force, right? This one and that one, and you found that my solutions should be correct because they are symmetry. It looks correct, right? So that's it. RARB done. Now we are going to draw the shear in the material. So what is the shear inside this material in every point from x equal to 0 to x equal to L? What will it be? And let's take a look. How many sections do you think will have these diagram will have? Actually, two. Two. Why? Because you can imagine that if you want to know the material, the shear force and moment in this material, you will cut that, right? So if you cut here, do you think it's an equilibrium to cut here? Right? Cut here, cut here, cut here. They are all equilibrium. You obtain very similar solution because their force doesn't change at all, right? So when you do, you can imagine that because the P here, so the form of the shear and moment in this section will be the same. But after this P, the other part will be another form. So if you cut here, cut here, cut here, cut here, they are all similar form. Okay? So basically, all we need to do is cut it. This is the first section. And then we cut it. The second section. You can see that I draw this dashed line randomly. As long as it in this region. As long as it in this region. All right? Okay? Right. So that's it. That's it. So let's do the cutting. One, if we cut and we leave left hand side. No, we need to leave left hand side, and we have RA here, and very important things here is that we cut one, right? And then because we want to see that X, maybe you can move here. How about that? So you will have X. Okay, doesn't matter. Okay, so you can have X. It looks better, but you can see that I can move this one anywhere in this region. Okay, so X. So now we leave left hand side and we draw downward V and smile M. Okay, downward V, smile M. So let's do the calculation. Right, so let's continue. Which means that, sorry, let me write down a little bit more information for this. The one here is actually describing x less than a, right? X less than a, because this before the p appeared. So this is a, x less than a. So let's do, you see, v equal to RA, right? V equal to I, according to the force Y equal to 0. Downward V, RA upward. So they need to be balanced. And how about N? N equal N. N is moment balance. The M here is counterclockwise, so it's become positive. All right, so this is positive M. And how about V? V is rotate about our A, right? V is clockwise, so it's minus. So minus Vx, the force on this x equal to 0. So it gives us m equal to Vx. Okay, so when x less than a, we have this force diagram, and then we can solve V equal to RA. Let me, do you think this one will be better? Do you think it's better? And we delete m plus. Right. Okay, two section, V and M. Okay, so in the first section, x less than a, V equal to RA equal to PB divided by L. We just learned that. So V is a fixed value. Ta-da. And this one is PB divided by 2. Sorry, L. Okay. And M, oh, did you see that? M is Vx. What is Vx? EB divided by L and times the x. So actually, this is a line. It's a line with a slope. Okay, gradually increase. Did you notice that? So when you have x equal to 0, x equal to 0, m equal to 0, so it starts from here. Okay, start from here. X equal to 0. How about here? X equal to a. So if you have x equal to a, so you will have this one, and this is b a divided by L, right? Because Vx, m equal to Vx. V is what? PB divided by L. Here, x equal to a, so PBA divided by L. This is the value at that point. So you can, you know the first point, initial point, and end point, and Vx is a line. So yeah, this is M in the first section. So you can imagine that, oh, the moment in the material gradually increased to the middle point. Understood? Next one. How about second x greater than a? S greater than a, again, we need to draw it. Okay, and here is RA. Again, we need to leave left-hand side, 当我 V, smile M. Okay, and in the middle, sorry, not middle, x equal to A, we have a P, and this is A, and of course, this is X. Okay, X and A, well, different. Right, so let's continue. We have two V equal to A minus P. Okay, so which is I minus P, which is equal to PB divided by L minus PL divided by L. So which is minus PA divided by L. Okay, so our V in the second section is minus PA divided by L. Okay. Next one, I'm going to do the moment balance. Moment balance and this is counterclockwise, so positive. So positive and minus Vx. Oh, minus PA, okay? You can guess that which point will be our origin. This one, okay? V with the X forcing on clockwise minus P with A as a forcing on and clockwise. And minus Vx minus PA equal to 0. So your M equal to PAL minus X divided by L. Okay, so V and N. So let's draw that again. Okay, so you see V in the second section is minus PA divided by L. So this is minus. Did you see that? Minus. So it's minus. And this will be minus PA divided by L. Okay. And did you notice that? What's the difference between this jump? P. So again, if you have a applied force on the material, it will immediately affect their shear value. Okay. Right. Next one. M equal to PA times L minus X divided by L. Wow, this is a little bit too much, right? But don't worry. Let's just examine the function. Let's take a look. So M is the second section, right? So it, of course, it will be suitable for, should be suitable for A, X equal to A. So let's substitute X equal to A. What will it look like? L minus A, which is B, right? So PAB divided by L, A is point. Okay, this one, okay. How about the final point? X equal to L minus X. The X here is L, right? So L minus L, 0, 0. All right, so this is 0. And you can examine that function again. Did you think this function is actually a linear function with the negative slope, right? So, and it is one order, the first order. So it must be a straight line. Sorry. Ta-da! Straight line. Okay, that's it. That's the for shear and force diagram, shear force and moment diagram. Right. That's it. And then you notice that this is kind of easy, all right? But don't you think every time when you meet this kind of problem, you need to cut it and you do the balancing, the cut it and balancing, balancing. Do you think it's taking too much time? So how about let's conclude? Let's using some mathematic concepts to help us to conclude several conclusions, several tips to help us to draw this in an even more efficient way. Okay, that's our purpose. So I will give you, I will introduce how to simplify this procedure. And we will do this problem again by using the tips we are going to introduce to you. And you will solve this problem within 3 minutes. Okay? Yeah, I can write down more information for you. This is x equal to 0. And this is x equal to A. And this is x equal to L. That's it. Right. And also I also want to give you some additional information to help you to double check if this is correct. Let's take a look. So, did you notice that the beginning point and the end of point of the end, they are all 0? Did you notice that? Do you think this is reasonable? Of course, because remember that our hinge and roller cannot take any moment. So if you have a moment here, can it take it? Of course not. This moment is in the material, So if you do the hinge here, the material cannot handle the moment. If you have a moment on non-zero here, well, it will rotate like hell. Okay, if you're using the hinge. So when you immediately see that, oh, this is a hinge, oh, this is a roller, don't hesitate. Just write 0, 0 this point. And then you can double check your functions. Okay, so this two, you don't need to write it. You see that you can get the 0 points there. This is the first things. Any other things? Okay, here, shear force. Do you think it will be non-zero here? Of course not, because here is the hinge, here is the support. The support must has a reaction force, especially when you have the P here. Okay, So you need to have RA, RB here. So you need to have a V downward to cancel each other. Not downward, sorry. You need to have a V to cancel this reaction force, right? So RA and RB will makes these shear force non-zero. All right. But if you see a free end, like this, okay, like this is a free end. This one, you will have zero shear, of course, because there's nothing here. So please think about the support type and the result of your moment diagram and shear diagram. You can find out, oh, this is possible or not. 听懂吗？总之就是，你看这边是完全不可能会有 moment 的地方，怎么可能会有 moment 呢？对不对？除非你有外加 m， 那这样有可能。但是这边如果是什么都没有外加 m 的话，你一定会归零的，这绝对是这样子。OK， 然后另外一个是说这边有 RA 跟 RB， 那这边的简历就绝对不会零啊，因为你想想看。你现在在画的是，例如说 x 等于，虽然是 x 等于0啦，但实际上你是画 x 等于0.00000000001这种感觉啦哈。所以你看，你只要这边有 RA， 你的那个微小的过去一点点 x 的简历是一定会有跟它去抵消的嘛，所以你这边绝对不可能为0啊，大概是这样子。所以你看你的 support， 你大概就知道，这边大概是要正的还是这边要是有值还是没有值，这其实蛮重要的，可以帮助你去。确认你的答案到底是不是对的 ，OK? Right. So again, I will give you 6 tips later. Okay? I will ask you to do exactly the same result. Okay, the same problems, and then you can solve this within 3 minutes. Okay? So next, then I will continue. So I will let you know how to conclude these tips. Okay. Let's go back. So the relationship between loads, shear, forces, and bending moment. So now we are going to see some cases, study some cases, and then we want to conclude the tips based on those cases. The first case we are going to study is distributed load. So we are going to see if there is a one section, one small section, little section with the width dx. If we move forward dx, and this dx has the distributed load q, what will it affect to the shear and moment after dx distance? Okay, we are going to see this. So previously, no matter how much m and v in the previous in this position, I just want to know what is the effect due to this q will make the m and v change in after dx. We just want to see that. We want to know that. Okay, so this is the typical. At this position, their v should be v and m. So if there's nothing here, nothing here, it should be v and m again, right? But now because you have the q, you will have the m and dv change. So we are going to see the q, dm, dv relationship. This is our purpose. So again, because we're going to do the force balancing. So we are going to make this Q as a sorry, effective to the x effective value, and then we are going to do the force balance for this. So sigma Fy equal to 0, V up, Q dx up, V plus dV minus equal to 0, and we can get this value. And we will explain this. What does that mean in next after 10 minutes? If you have any questions, just come to here to ask me. Thank you very much.
这个x 等于2/4本年的伽马的时候，它 x 不是本来没有单位，可是它变成2/4伽马的时候，它就有那个 RAD 的单位。
RAD 其实它也不是单位，
它是一个
对，它是一个 RAD， 它其实也不是一个单位哦。对啊，它不是一个，
它算是一个，也是一个
对，
就是一个好，
它是一个要怎么讲啊？让我想看。对你说的感觉起来蛮有道理的，不过我看一下哦 ，epsilon max 伽马为什么有点给伽马的 I gradient 这个东西是一个，对，你看哦 ，gradient 它其实是一个比例，它是当它转一圈的时候，它这个2派，然后派我们给它一个数字叫3.1459。那所以实际上你的每一个东西，每一个 gradient 都可以想象成是几分之派。对对对，比如说派就是90度。它其实是一个，它跟 epsilon 其实是就是那个percentage 其实也是类似的概念。对。
这种题目，它的 phi 会是这边加上这边，还是它全部的 phi 都会是一样？因为它这种就是 pure 形式。
没有，它的 phi 会变，它的 phi 会变，就是这边
半径不一样。
对啊，对啊，它的应该说一直它都一直会变啊，它的对啊，它就有2段 phi。
因为它是这边的 angle 就会是这边加上这边。
看一下哪里有 angle of twist。
这下面。
If the angle of twist is on the determination of the shape。对，它如果说它只有这整个只有给你一个值的话，那就是2个都要加起来，加起来是3度这样子。
好。
对。
对，
谢谢。
这个就黑色可能，然后就是然后等它第一做这个 x 2的 x 是3的部分，这个就是就是 x 2的 x，这样子是错的，就是 x 特别是 x 2的 x 是小是错的。另外是中空吗？还是因为 homogeneous 这个字典错了？
Figure 2 is union of figure 1, which description is incorrect. False is false. X1 cause stress concentration. And how stress X2 and X3 are approximately the same because the material is homogeneous. 对，没关系。然后先看一下，if we want，
这个
耶，
抱歉，
好，
明白。
我要这张图，对，好，然后 if we want to choose a point for the most theoretical area, we choose x4. If we choose for the most theoretical, the normal stress, it should be x5。然后等一下。If we stress them to approximately the same. 我忽然觉得有一个小问题，会不会其实这个是在里面，这个在外面，然后对，
这完全看不出来。
对，觉得如果是看不出来的话，因为我记得，对，但是我很担心的是，我当初做这张图的时候，那我是意思是这样吗？
他说 incorrect 是 B 选 D，所以
对，应该是不一样的。那我很怕是说，好，我回去把我以前的图翻出来，因为这是我自己画的。然后我很怕就是说，我给了助教，然后那个解析度的问题，然后让那个点变大了。如果是这样的话，那这里可能就会送分，因为就是其实这样看起来好像没有。如果它都是在中间的话，那的确啊，对啊，的确它这样是对的，应该是吧？好，对，
A 为什么对？就是 more than anyone case extremes。
对啊，stress concentration 啊，它一定会。没有，它虽然是中数，但是它东西它上面还是有一个板，不然它无法施加这个力。对，所以说这个 x1 是绝对是对的，但是竟然那时候写，我猜可能真的是因为点的问题，它点变大了，然后就看不出来一个在里面，一个在外面。我回去翻一下我这张图，然后如果今天我在上面的点比这个还要小，可能就要送分了。如果今天他无法看得出哪边是正里面或外面的话，那当然就会是一样。但是如果今天我画得出来是这个东西看得出来在里，这个东西看起来外面，
内壁
跟外壁的问题，对，
内壁
就会不一样，对，尤其是靠，哎，等一下，那我知道了，其实它那不是外壁跟内壁，就是我在想是不是我那时候的出题，我要回去看一下那个点的大小。如果点大小其实不是我的重点的话，那我那时候的题目，因为那是大概3年前之后，我已经忘记我那时候怎么出了。搞不好他就是说，他其实不是因为 homogeneous 而一样，而是对。总之我觉得可能是个点的问题。好，我回去看一下，我记一下。好，不好意思，谢谢你告诉我。不给你传讯息哦，不然我好。
我已经全超过了8了，喂。Good. So let's continue. 对，我想要讲一些什么，但是就不知道讲什么。我是说，这无聊分享的事情。原来我这个礼拜过得这么无聊，真的想不起来发生什么事情。对，我觉得过一天好快啊，一天就过好快啊。昨天没做什么事情就你知道，我会跟我小孩子说，哎，来告诉我你今天发生什么事情。然后他讲完以后就会说换你了，然后我就好，然后我就说我今天到学校，然后我就常都是在讲，我在跟学校的学生讨论，跟老师讨论，然后上完课，这就是我一天就结束了。他说，哎，怎么每天都这样子？或者说我写个文章。他说你怎么每天都这样？我说我的工作就是跟人讨论问题，然后就改文章写文章。哎，这是我的职业，就这样哎，好像就没有别的人。因为我每次跟他讲，他就说怎么每天都这样子，然后我觉得是不是有点就是无聊这样？对，好像真的没什么事情。但是我跟他讲到我看剧，但是我不能跟他讲内容是什么。例如说周楚除三害，你可以跟5岁人讲吗？不行好吧，怎样？对，好，所以我无法跟他讲太多。然后，对，后来现在发现一件事情，就是其实我们以前小时候看的卡通，其实都还蛮，要么就是政治不正确，要么就是非常的暴力。你有没有发现这件事情？就是例如说七龙珠，七龙珠是我那个年代，抱歉当然就是例如说某个发射什么气功什么什么之类的，就把人家打爆打成碎片什么什么，其实还蛮残忍的呢，打他肚子什么什么的，其实都还蛮暴力的。那你知道现在的卡通都已经不是这样子汪汪队，对，你看汪汪队，汪汪队你很开心哦，你很喜欢看吗？你超爱，看不出来。那你跟我儿子应该会聊得来。就他，你知道它里面虽然有所谓的反派，但实际上他也不是真的反派，就是对，就是他都是现在的卡通都是去救人，rescue。现在基本上迪士尼卡通大部分都是 rescue 的那一类型的你看例如说汪汪队就是救援队嘛，对，好，这是第一个。我后来发现，你知道连变形金刚现在都有现代版。以前的变形金刚在我这个年代的时候，他们是博派跟什么忘记了，狂派，他们要互相打，对不对哈？然后置对方于死地这种，对不对哈？ 他们是打来打去的。然后我最近就在看小朋友的 Transformer，现在的 Transformer 也是救援队哦，它是救援学院，就是 Rescue Academy，知道吗？就是他们的主角已经不是那以前什么狂派博派的，他们主角就是学生，就是像你们一样，在学院里面学如何救援。然后我就觉得哇，现在大家都是世界和平，对他已经没有那种，然后连忍者龟都非常的，忍者龟都已经是那种限制级，对他们来说限制都不能看，真的，所以说觉得哇，现在的很注重哦。然后仔细想想看，以前的那什么灰姑娘啊、白雪公主啊、睡美人啊，其实都非常的政治不正确，就是白雪公主跟7个小矮人。然后你也想想看，你用现代的成人思想在想，为什么要是7个小矮人？你不觉得很怪吗？就是为什么？因为如果不是7个小矮人的话，如果是7个成年男人的话，就有点怪怪的。所以他们为了要把这件事情合理化，就把它变成7个小矮人。那这时候你不觉得很奇怪？这样对7个就矮人，就会有一种非常不合理的，就是刻板印象。所以我觉得哇，那以前的现在仔细想想看，都非常的怪，都非常的奇怪。那所以我现在非常喜欢把童话故事改编的故事，例如说《Wicked》，我不知道你们听过《Wicked》。在他好像最近要出电影哦，但是在10几20年前，他刚在舞台剧发展，就是《绿野仙踪》的那个绿色的女巫，那个是绿色吗？她应该是绿色吧，就是坏女巫。她其实不是坏女巫，她其实是不得不，然后人逼她，所以原本的反派结果变成其实是不得已的，或者怎么样的，她其实没有那么坏，这种我就觉得还蛮好看的。然后像那个什么，那个头有尖的那个叫什么？睡美人啊，黑木耳不是啊，菱角，那个叫谁啊？啊对，Magnificent，哎不对，那个反正就是梅杜莎，哎不对啊，黑魔女，就那个，他不是有出第二集吗？就是安吉丽娜·裘丽演的，那也是很好看。我也觉得就是他把反派就是做成其实真正的好人才是对啊。你不觉得那些童话故事听起来都超 creepy 的吗？都超怪，那些好人其实都是超怪的听起来不合理，对不对？然后王子直接去亲公主，然后睡了100年，超怪的，真的超怪。所以现在想起来就是。反正我还不太希望给我小孩听那些然后你看糖果屋哦，对，糖果屋，你知道那2个小孩直接把女巫推到，你不觉得很恐怖吗？这个，然后大野狼直接把他丢到，你不觉得很恐怖吗？嗯，然后我就试图为大野狼讲话，他只不过只想要吃顿饭而已，他只是肚子饿而已，对不对？对我也不知道为什么，唉，anyway。好，就是觉得有一些很有趣的现象，就是会让我思考。然后哥哥爸爸真伟大这个歌也超怪的，对，就是你看现代人哪想要去上阵，我们要 peace，谁给他哥哥爸爸真伟大，真是OK，next one。So let's continue. I just talking about the stories and cartoon animation in my age are really different from significantly different from what my kids receive now. Yeah, that's it. I just think that all the stories when I was young I heard are so dodgy, so creepy and strange. Weird. Anyway, so this unit is N. This unit is
Newton divided by m. Right? So the unit. Okay, so let's do the force balancing. So V up, Qx dx up, V plus dV down. Okay, so V plus Q dx minus blah blah blah. dV divided by dx equal to Q. We can find that V. So there's a really important conclusion that we can get, which is forgive me. Sorry, wait a minute. Can I see that? Okay. I wanna, sorry. Notes. Chapter 4. So I want to make a conclusion in this 没有连线，可恶。好吧，算了。因为我没有小抄了哈，我要怎么做会比较好？题目截图 ，OK，good。哎，你其实看不懂我在干嘛，对不对？好，然后接下来我就要贴上去。哎，不能贴。All right， 我把它背起来。The change in shear force is the magnitude of the point load. The change in shear force is the magnitude of the 不对 The change in the shear force is the area of the distributed load. So, 1, the change of the value of the shear force is the area of the distributed load. Okay, so this is our conclusion, and which is corresponding to this one. Okay, the change in the shear force is the area of the distributed load. You see? Sorry. It should be the second. Sorry. I'm sorry. 我背错了. This is the second one. I'm sorry. Sorry, this is the second one. So if we do the dx to the right, and then we do the integration from a to b, which is vb minus va, so you can see the change of the value of the shear force is the area of the distributed load, because we do the integration, right? So this one should be corresponding to that one. I'm sorry. And I will write down another one later. Okay, I'm really sorry for that. So this one is for the second. All right, so you can see this is shear force difference. So this is the change of the value of the shear. And this one is the area of the distributed load. Okay, so So then I conclude the second part, and then it will corresponding to the next, one of the 6 tips. The first one is that我直接翻了，如果翻的不好的话，请不要，请多多包涵啊。简历图的斜率是相对应点上分布负载的值，所以 the slope of the shear diagram the slope of the is the chorus, the distributed load, the value of the distributed load. Okay. You see the slope of the shear diagram. You see dV over dx. dV over dx, of course, it will be the shear diagram's slope. The shear diagram slope equal to Q. So the slope of the shear diagram is the value of the distributed load. Okay, so this is the first tip we conclude in this. And then if we do the integration for this, you can get the change of the value of the shear force is the area of the distributed load. That's it. 我感觉得这边有点挤。OK， understood。中文讲一次，就是啊，我力平衡以后，我们就发现 dv 除以 dx 等于 q，dv 除以 dx，它不就是 v 这张图的斜率吗？斜率竟然是 q， 哦，所以简历图的斜率是对应点上分布负载的值，这就是我中文给大家的 tip。If we translate to English just like that, the slope of the shear diagram is the value of the distributed load. Okay, this is the first one. 第二个就是你把它积分以后，你就会发现那一段的简力差会是分布负载的面积。Okay, the change of the value of the shear force is the area of the distributed load. 中文就是简力的变化量是分布负载的面积。这样。So there are 6 tips. I introduced 2 of them. Now, let's talk about M. What about M? So sigma M blue dot equal to 0. So V is we don't need to do that. We don't need to see that because it has 0 force on. So now for the force balance half dx. So this one M. What is M? Pass clockwise. Clockwise is minus. Okay, minus M. And Q counterclockwise positive. Positive Q dx. Q dx times its forcing on dx half minus V plus dV. This is clockwise minus V plus dV, and this forcing on is dx. Okay, and M plus dm counterclockwise positive.
Okay, sum and not together become 0, and then we can notice that minus n plus n, okay, cancelled, and you notice that dx is really small value, right? Dx times dx, we can neglect them because double, right? Square, okay? Dx times dx, small times small, very, very small. And dv and dx, small times small, dv times dx, very small, okay? And then after that, we have dm divided by dx. Okay. So the third one is the slope of the moment diagram is the value of the shear force. Okay? The slope of the moment diagram is the value of shear. So which just V is the value. And then it will be corresponding to that point, the point in the moment diagram, and it will be there, the value will be their slope. Okay? And the same concept, if we do the integration, all right? So if we times dx to the right hand side, do the integration. So this is the moment differences, right? And this is the area of the shear diagram, very similar to what we looked in the above. So again, 4, and the change of the change of the value of the moment diagram,算了，不要写 diagram 啊 ，moment the change of the moment change of moment is the area of the shear diagram. Okay. Very similar. So you can see that the relationship between shear and distributed load is very similar to moment to shear force, right? Their relationship is really similar. So I conclude 4 tips among the 6. 还是 6嘛，我也忘记了几个。246, 246, yeah, 66. Right. So, in Chinese, I guess I need to use Chinese to emphasize that. 好，我们平衡以后，我们就发现，哎，弯举的斜率就会等于剪力值，当下的剪力值。所以你去看上面那张图的那一点的剪力值是多少，你就要确认下面的弯举的那个斜率是不是对的。大概是这样的。我们等下可以拿刚刚我们算出那一题来检验一下。然后接下来第4个就是，如果你做积分做完以后，然后你就会发现弯举的变化量，一段的弯举的变化量就会是那一段的简历图的面积，它的下面包含的面积。那就跟你不觉得分布载重跟剪力的关系就会等于剪力图跟弯举的关系吗？这种一层一层一层这种感觉。OK， 好，就这样。所以你会看到这黄色的这4个就会是等一下这里，其中的4个。好，我们接下来会继续推导。OK。
OK 吗？哦，所以原来你们这个年纪也会喜欢汪汪队哦。那你有没有去参加汪汪队路跑？太贵了，太早起了。我早就报名了，所以当天你就看到我跟我小孩在那边跑3.5公里，但实际上它就是卖东西嘛，那就卖东西，对，很贵，没错，但是我是只好买了，对，然后还要训练他要去跑3.5公里，这还好，应该蛮简单的吧。然后现在还有 Spy 成 Family 的慢跑，我真的是很佩服商家怎么可以这么厉害。对，我也很想要去参加 Spy 成 Family，月额好挣这样。对，真不错，虽然他不会煮饭。OK，next one。Next, distributed load. So next we talk about point load. The point load. So again, let's take a look. The Vm in the left, and again dx for the width. And what kind of effect will the P make the V and M changed? Okay, and then maybe you may notice that why previous one is dx, dv dm, why this is v1 m1. Okay. This is kind of important because why this is m1 v1 rather than dm dv? Why? Because this is point load. It's focused. So because previous distributed load is that it is relative to the length of the dx. So if the dx is really tiny, the m1 and v1 become dm and dv. But here, this is point load. The point load is numerically smaller than dx. This is just one shot. After that point, bam. Okay, so no dx integration is needed. So after this dx, once it passed this p, m1 and v1 are actual value. We don't need to do the integration, right? But previous one, distributed load, is you need to do the integration. So this is dm dv. I hope you can understand this. 中文讲一遍，为什么这边是 m1 mv1 因为这个 p 不需要积分啦，它就是你过了那个点，那个点是就是无限小的点哦，比那个 dx 还要小哦。你一瞬间过去了，它就是一个值 m1，它就是给你一个正确的值了，你不需要积分了。但是前面这个它是走一个值，你还要给它一个距离，你还要积分它。所以这个 dm dv 其实是跟这个 dx 有关系的 ，OK？ 所以你必须要积分，所以你必须要 dm dv。但是这不是，这根本不需要积分，你给它 p 多少，它给它的效力 m1 v1，它就是一个大的值，不能忽略的值的变化，所以这边就不会是 dm dv。OK？So because this is point load, the effect is immediate. Okay, when you apply that, the effect is immediate. So now let's continue. So we do the integration and sorry, not integration, force balancing. So force balancing is that v minus v plus v1 is minus. So minus v plus v1. So v1 equal to p. Okay, you notice that this is another conclusion. V1 equal to P. So the phi. The change of the shear force is the value
of the point load. Okay, and then you can notice, you can check if this tip suitable to explain the problem we just, the first problem, which first example. Okay, so in Chinese，好，你做完这些，叫什么？力平衡以后，你就会发现 V1 就是 P， 也就是说你的 P 一加上去，你 V1 就会改变，就加了 V1，这个 V 就等于 P。The change of the shear force is the value of the point load， 就是剪力的变化量。这是剪力变化量啊，剪力变化量是是集中载重的大小。OK， next one we do the moment balance. We do the moment balance again to the blue dot. Okay, N is clockwise minus, and P is counterclockwise plus. And okay, again, this is half dx. And half dx, and this is clockwise, counterclockwise, so it's positive, and v plus v1 clockwise minus m plus m1 counterclockwise plus equal to 0. So m1 equal to minus p half dx v dx v1 dx. So you see that you see m1 is a really big one. Is a value. You don't need to do the integration. So because dx is really tiny value, so you can just directly ignore it. So n1 become 0, 0, 0. Okay, so n1 proportion to the 0. So your point load won't affect the immediate m. Okay, your point load won't affect immediate m, but it will has effect if your shear force diagrams continue grow. So you will have area underneath, and then you will change the m. So you see, V need a area to change the m. If there's no area change, there's no change of the zero, no change of the moment. Right, and can you see that? That's it. And then the rate of change in moment, well, it should be, well, this one, the left-hand side, right-hand side, the rate of change. Actually, the rate of change is actually the slope of a change. So this one I talked in the previous page, so I will ignore this. 这一页已经讲过了哈，在前面那一页，你看他说是 rate of change in the moment， 其实就是斜率啦。好，左边的斜率就是左边的 v， 右边的斜率就是右边的 v 啊，所以这边的 v 左边是 v， 右边是 v 加 v1，v 加 v， 所以其实这前面已经讲过了，所以其实都还好了哈。OK, that's it. Point load. 其实我很不喜欢跟别人跑步，跑步是很私人的事情。你知道这句话谁还讲过吗？金城武。金城武曾经讲过这句话。没有啊，那是他在演戏的时候，那好像叫什么重庆森林吧。他就讲跑步是一个很私人的事情，对我觉得跑步真的是一个很私人的事情，就是你可以，就如果你跟别人跑步的话，你就会想跟他聊天啊什么的，你就会觉得，啊，怎么了吗？私人的事情，其实也很私，没错啊，因为你会流汗流很多啊，很私人。
私人的事情。其实真的很湿，没错，就是它会流很多汗，真的。你像，其实有的时候下小雨的话，其实也是可以跑步的，因为你去背淋雨，跟你去大太阳去跑步，其实一样的事情。唉，所以啊，如果今天要去，我就很无法理解，就是除了买纪念品以外啦，不然的话，我真的无法理解，就是为什么要报名去跑马拉松，无法，又要花钱，然后公路去跑马拉松，有没有人参加过封路去跑马拉松比赛？目前有吗？没有，好像都只有中年以上的人才会做这种事哦。对，我有很多朋友都去跑这种马拉松，对吧？我们就来看看10年、20年后大家会不会去做这件事情。Okay, next moment. Right now, again, and no, you can treat that as a concentration moment. Okay, concentration moment. So again, M1, V1. You don't have to do the integration to get the value. So M1, V1 again. Then let's do the sigma Fy. And then you find that, oh, V plus V1 equal to 0. So the moment won't change. Moment, I should say, applied moment. 施加的 applied moment won't change the shear value. Okay. Next one. If we do the moment balance to the blue dot, okay? So again, clockwise. So minus n no, okay? And V1 plus V1, V plus V1 is counterclockwise minus times dx forcing on, and n plus n1 counterclockwise plus equal to 0, m1 equal to n no. This is our conclusion. M1, the external M1 equal to n no. So the M1 is the change of the M. So again, this is really similar to what we've done in our first example, right? So 6, the 6, so the change of moment is the value of the applied moment. Okay? The change of the moment is the change of the moment in the material is the value of the applied moment. Okay? Right. However, I'm going to give you a concept. Be careful here. This is our main surface, right? 主角面. These are our main surfaces. So when we apply M no, so for the main surface. For the main surface. For the main surface is M naught is going to bend the material downward, right? So you can imagine that this one is going to make it downward, right? It's a crying emoji, okay? But in order to balance it, the material, the M1 has to be to bend upward, right? So M1 need to be balanced to upward. That so one downward and upward, they need to balance it. So in this case, the moment of the material in the material increase. Okay. So the reason why I talk too much here, because your senior, 学长学姐, your seniors sometimes cannot identify when we apply M norm, it should be increase the M1, increase the M or decrease the M. 是要增加还是减少? So they don't know the direction of the M plus M1. They don't know the direction of the M1. Okay, so this is the question that or the description that you can ask yourself. Okay, when the M norm, what kind of direction will apply to the what kind of direction will the M norm apply to the main surface? In this case, downward, right? So the downward, in order to balance it, so the M1 needs to be increased to balance that upward, right? To make it downward, upward, and cancel each other. So M1 need to be upward. So upward means that you can increase the M. So after the M norm, the material M moment in material should be upward, so should be increase. 简单来讲就是学长姐常常无法分辨说，哦，我虽然知道它的改变量是 M0 这个值，但是他不知道是要往上加还是往下减。那这时候就要知道，就是说你加了这个 M0 会让 M1 怎么样去采取行动。你的 M0 如果是往下凹的话呢 ，M1 就要把它往上搬回去。那如果是往上搬呢，是微笑曲线，就是正的。但如果你今天 M0 是让主角面微笑的话，那不行啊，它要把它搬回来，所以 M1 就会变成往下弯，那往下弯就是负的，所以这边就是要在图的话就是往下减，所以你这边要小心，你要小心它的值就是正负号就对了。Okay, so I hope you can understand what I'm talking about. And then you see, I have 5 minutes. 5 minutes. So now we conclude the 6 tips, and I have 5 minutes. So I'm going to solve this problem. Solve the problem 1. Previously, we're using force balancing, right? Now we are going to using these tips to help us to solve this example in 3 minutes. All right.
I have plenty of time. So drink some water. So I list all the tips in the problems beside the problem. This one, okay? And I'm sorry that I don't want to solve the RA, RB again. Okay, can I just 作弊一下? Can I just copy this? Okay, that's it. So now I'm going to draw the diagram. The diagram. V M 0, 0, X, X. Okay, so now RA, the change in shear force is the magnitude of the point load. So it's RA upward. Okay, RA upward. Ta-da! RA. And RA is PB divided by L. Okay, and there's nothing in the middle, so nothing change in the shear force. You see, the change in the shear force is the area of the distributed load. There's no distributed load here, no point load here, nothing change. Okay, now I meet a point load here. The change in the shear force is the change in the shear force is the magnitude of the point load. The magnitude of point load P, so I push downward to the P, and which is PB divided by L minus P. So this is minus PA divided by L. You can check. And then nothing change in between because there's no distributed load and no point load. So nothing change. Okay. So here is the result. Okay. Done. Next one. Moment, because we only have 2 minutes. I need to be quick, otherwise I will be fail. Okay. Okay, so next one. The area of the surface will be plus PAB divided by L. And this area is minus PAB divided by L because we are going to use the area of the shear formula. So you see the change of the moment diagram is the area of the shear moment. So if we can start from 0 and the change of the value of the moment will be the yellow value PAB divided by L. So this is the yellow point, right? And because the slope of the moment will be equal to the shear value. You can see the shear value are constant. So the slope of the moment is exactly the same. So it will be the straight line. Okay, and the change minus PAB divided by L. So it will make it back to the 0. And of course, the value of the shear is constant. So, and it's negative, right? So the slope is negative and a straight line. So yeah, that's it. I know I make it too quick. Okay, I'm sorry. I will explain that again tomorrow morning. All right. But I just let you know that
It can be really quick if you are familiar with the 6 tips. Okay, if you have any questions, just let me know. Thank you.